Okay, hey everyone. This is the next update on my project, Rags to Robots. So, what I've done in the last couple of days is been focused on a few things. One is here you can see improving the future simulation of different neural policies. You can see here there are just 3 different possible futures, and the robot is able to simulate those futures and play them out, and we could select one, and that's kind of our new state. In addition, I've been kind of reworking the base starter policies that don't neural networks. So the first one is just Ragdoll here, which disables the torque on the motor, so you just fall over. And next is Tin Soldier, which essentially is just designed to hold the pose, whatever it is, of the robot. And if you do that in the default pose, he will just fall over. Next is a mild chaos policy, and see that it just wobbles around a little bit. And finally we have Haywire, which is kind of an extreme variance motion policy. And now if you look right here, I've built kind of the first Terramechanics system. So this is just sort of a dithering shader involving basically this checkerboard of dirt, my idea here is sort of like perturbations in the initial dirt are kind of on the surface layers of the dirt are kind of pulled over between the checkerboard. My main desire here with the design was to start with a really nice looking checkerboard, and then through player motion and through things moving around on the terrain, the checkerboard is slowly destroyed, essentially. Right? Okay, so I trained some other policies. Here's the current state-of-the-art policy that's trying to stand up, and it doesn't work yet. So there's a lot more that needs to be done to build base policies for the robot to get useful functionality, like even just standing up and walking are a lot more complex in 3 dimensions, and they're basically simple policies like walking and standing do take a lot of training, but they're likely solvable with the right reward shaping approach, and I've probably been using an incorrect reward shaping to get the right behavior. And so I have lots of ideas about how we might do a better job of reinforcement learning, or trying other techniques like symbolic regression to get the robot to stand. But Tin Soldier is doing the best job so far. On the other work I've done has been starting on the what I like to call the neural network training area, or this area here. And so the idea here is, before we train any neural networks, we need the basic tools to select sets of our motors, and start with very simple things like enabling us to run like simple sine functions on the motors, right? And set whether things are limp or stiff, and from here we'll be able to design simple rhythmic policies which can be part of a graph, eventually a graph, rather than the output of the robot being a purely single reinforcement learning based neural network. It will be based on a graph where particular joints on the robot are controlled by particular policies, and things like these rhythmic behaviors I believe can be effective inputs to neural networks for creating essentially simple rhythmic behaviors like walking. Now, whether that's designed or learned is an open question. I generally think where my thinking has led to with the development of this game is the idea that it's sort of more of a serious game than other games, and what I mean by that is that it's, you could say maybe like it could be designed in a way that makes training general purpose humanoid robot locomotion policies accessible and fun to an ordinary person who wouldn't necessarily have to write software but could experiment with reward shaping and essentially build a general purpose locomotion policy just through a simple video game. I genuinely believe that a large amount of generally intelligent robot locomotion behavior could probably be created within a video game just by people having fun and pursuing video game objectives. And so whether that's it, but of course the idea here is that human beings are going to be initiating various reinforcement learning policy runs and then essentially composing them. A good example is often in video games you have a different animation graph on the lower body than on the upper body. The same is very plausibly true in general intelligence robot locomotion, where the lower body of the robot, the various thighs and actuators down here, might be trained to be trained in such a way that the behavior of the upper body may be fixed or chaotically randomized, such that the lower body behavior is robust to upper body independent behavior. And this can generalize to various sets of torqued objects and different embodiments, right? Because we might have an upper body behavior which is trained and then we put it on a wheelbase and it can still perform the same tasks, it's just on a wheelbase. But you can see what I was working on here is trying to get a better approach to understanding the distribution of initialization poses in a reinforcement learning run. So rather than starting the training from a singular pose, my idea is that we pre-simulate the robot for some amount of time with some randomized or designed policy. It would be simpler or more random oriented than neural networks, but you could also use a previously trained neural network as input to generate initial distributions, whether that's orientation and position, or also including velocity initialization and torque or angular velocity initialization as well. And so this is just the idea I have, which is that by being able to pre-visualize a sample of the spawn distribution of the robot, it can help to train better policies because it can be understood where the robot's starting from. And this is still under hugely, massively active development. And will be changed a lot by the final game, but yeah, this is just the idea that we have some sample or distribution of poses, which is generally probably going to be used for more than just spawn initialization, but wherever you want to use like a pose within a graph, like within a graph pipeline involved in training a general purpose humanoid robot locomotion policy, you could just drag one of these poses in and use it as data. So that's pretty much all on the actual gameplay. And in terms of where we are at with the story, so here's like an example I like of kind of how I'm thinking of approaching the story. Of course, this is with an incorrect robot, right? But it kind of gives you some ideas about the ideas I have for the world, which is mainly that you've got the Sky City, the Alita Battle Angel style Sky City, but also it will be different from that trope in the sense that there's probably going to be dungeons as well, and more of a fantasy element, and more, rather than creating isolated worlds, you could actually go up to the Sky City as long as you are your policy is able to pass various social etiquette tests, and your robot doesn't smell too poorly from playing around in the trash. In terms of how I'm going to make this game work from an economic perspective, something I've been considering is just making the game a free-to-play game, and then providing the ability to for people to rent cloud GPUs to train their robot policies. And this would be something which is paid, because I'm not going to give people free compute. And I thought it could also be reflected in a sort of narrative sense as well, that the aristocratic robot society that lives in the higher and better parts of the world, some of their trash falls down. And so this was my idea for an element of the design where you start like where there's this used billboard in the landfill, and it kind of could give like a sense of the idea here is like, yes, it's a serious game, like it's about real robot locomotion policy simulation, but it also needs to have some cultural element or cultural exploration of robot society, and what it might be like if there were super intelligent robots that were wealthy. I think this is a very interesting domain that hasn't really been explored very much. Just the idea that we often think of robots as slaves or servants, but it's equally plausible that once they become intelligent, they can become free, and due to their various memory and computational advantages compared to humans, it's very plausible they could easily become more wealthy and competent than humans. But of course, this game itself doesn't necessarily have human civilization, and this was my idea to design a world where what sort of world would it look like if agriculture was more robot oriented, or things like this. And that's mostly all. So I look forward to finishing some of the initial policies for walking, because I think once we have a walking robot, then a lot of the game will be more plausible from a design perspective, because right now it's hard to get the vision for the game prior to the robot walking around.